Okay, now in this video we are going to play with colored images. So let's first give a heading. Let's say RGB images in OpenCV. So both in OpenCV and in Matplotlib. Later we will see it is better to not write RGB and it is good to write colored images, but let's see when we get to that what's the problem with writing RGB here. Anyways, first of all, let's read an image, an RGB image located, for example, here. Let's say we have a tulips, the image of tulips. Control C, and then we go back and we have, let's say, colored image. Let's say C image, colored image, which is PLT, matplotlib.imread. This R, and that's it. We read that image and we are really good to go with that, because here we have plt.imshow CAM, and that's our tulips image. That's a colored image. It is no longer a grayscale image. It's a colored image. Let's actually display different channels of it, see the data type and the number of channels and dimensions and all that. So first of all, let's see the shape of this image. So the shape is, it has 638 rows, 640 columns and 3 channels. The first channel is red, the second channel is green, and the last channel is blue. We can display red, green, blue channel individually as well, and we will do that in a while. Next we see the type of this object colored image. The type is, it's a NumPy array, and its D type is CAM.D type. Its D type will be that each value in there is an unsigned integer 8 kind of object. Now let's display this image using this using different channels. Let's separate out different channels of this image. For example, red channel is CAM everything 0. That's the red channel. The green channel is colored image second channel. If you remember the shape of this image, it has 3 channels, or sometimes called bands. The first channel is red, the second channel is green, and the third channel is blue. Let's have blue channel as well. So these are the 3 channels. Now next what we do is we actually write a code to display the red, green and blue channel in combination with the original image. So let's write plt.figure. Let's say we have only one figure right now. We will use the subplots here. So plt.subplot, and we use 6 subplots, 2 by 3, and so this 2, 3 is actually 2 rows, 3 columns, a grid of plots. And in the first plot we are going to use plt.imshow the original image CAM, and we will plt.xticks. We will use that. Xticks is just we will remove these xticks, these kind of labels that are here, and we can remove the yticks, the labels that are here, by removing that, by just placing an empty array inside. plt.yticks, that's 0. And we can call plt.show function just to so let's just check whether it is working. Yes, it is working. So what we next do is we actually copy this block of code and paste it 6 times, and in each of these code blocks we actually use different kind of, so control V, Control V, Control V. So the aim is to display the image along with its different channels together. So let's see. That's 2. And again this thing, that's 3. That's again the same thing. And then at 4, let's say we display the red channel with CMAP as gray. And at 5, we display the green channel with CMAP as gray. And the last but not the least is the blue channel. Let's display the blue channel as well here, which is blue. Remember, we already have separated out these channels, red, green, and blue. And CMAP equals gray. I'm writing this CMAP gray because each individual channel is it looks like a grayscale image because it's a one matrix with gray values in it. plt.title as red, and we can give different titles to different subplots. So for example, this is green, and then we can give a title here as blue. And if we display that, you can see this. So that's the same image copied multiple times, but that's a red channel of this colored image. That's a green channel of this colored image, and that's a blue channel of this colored image. So the top row is actually the same image repeated, but the bottom row represents the red, green, and blue. If you see a yellow color, or if you, for example, see this pinkish color, it has some contribution from the red, some contribution from the green, and some contribution from the blue. Here, the brightness of red represents the contribution of red color in this image. The brightness of green represents the contribution of green color, and the brightness of blue represents the contribution of blue color in that. Here I want to mention one more thing, that if you, for example, read the image using OpenCV rather than Matplotlib, there is a little difference that you need to know, and let me write that here on top of that. If you read the image using OpenCV rather than Matplotlib CV2, for example, then there is a difference that you will be now noticing. And the problem there is, in fact, the OpenCV by default does not have RGB ordering. OpenCV reads the image in BGR ordering. So let me mention that here. So for example, mention that here. OpenCV reads as BGR ordering. So Matplotlib, for example, and several other packages, they read as RGB, but OpenCV reads the image as BGR, which means the first column really, the first band is really the blue band. The second band really is the green band, but the third band is the red band. So if you use OpenCV, you need to know the ordering is not RGB, the ordering is BGR. And that's precisely the reason when I said that I should have written here colored images rather than RGB images, because this OpenCV does not read the image in the order of red, green, and blue. Rather, it reads in the order of blue, green, and red. But we can always alter the order, because once the image has been read, the image now is in the form of NumPy array, and we can play with the NumPy array by just changing the order of different channels. For example, keep the XY locations and reverse the order of the channels. So what will happen is now the BGR will reverse and get RGB, and rest of the story will stay the same. So for example, now we will read the image in using this OpenCV, and we will display, let's say, for the image using Matplotlib. No problem. We can display the image using OpenCV as well, but I just want you to know the difference in ordering in OpenCV and maybe the several other packages that by default uses RGB. Now that we know how to deal with this BGR, now let's change the RGB patterns in, for example, let's play with this color image. Let's change R values and G values and B values for a particular patch and see what happens in the image. So for example, let me use the R and change the R values, for example, from 100 to, let's say, 400, for example, and the columns, for example, 100 to 400, and let me use this 255 value for R band, and for the same index let me use the values, for example, 100 to 400 and 100 to 400, for example, and let me use that value as 0, which means I'm placing in this particular patch I'm trying to place the red value 400, and because I'm removing green and blue components, so this particular patch will contain purely red values 0. And let's say my color image is basically my color image is at 0, it contains red. My color image at 1, it contains blue, green, and my color image at 2, it contains a blue. And after that I just copy my the code that I already am using, and let's see what happens, because there will be a particular patch that will be showing a different way of different color. So let's see. So I copied that code here again by altering different bands, and hopefully you can see this is what has happened. So the red color, that's a red patch, and you can see the contribution in the red is highest there. That's and the green and blue, they both are very small contribution there. And by the way, we can change these values. For example, rather than just red, we can change these values. For example, the red contribution might be 100, the green contribution might be, let's say, 50, and the blue contribution might be 70, and then we may experience a different color, not an R, G, and B, but a different color like this purplish kind of color. So that means you can play with RGB images by playing with individual bands and intensities. And one thing that you need to notice or remember is that if you read an image using OpenCV, remember the order is not RGB, the order is really BGR. Yeah, so hopefully you get a very good understanding of colored images in this video. In the next video, we are going to talk about color space transformations. The color space is not just RGB or BGR. There are other color spaces like HSV or HSB or CYMK. There are so many ways to construct these images using different color codings. So let's talk about HSV in the next video. Hope to see you in the next video.